Okay, what were the key points from this lesson? Well, there's a couple. First, we can use regression to find correlations between a single dependent variable, y, and one or more independent variables, these x's, x1 here and x2. If it's just one explanatory variable or independent variable, then that's known as simple regression. If there's more, it's known as multiple regression. The coefficients, these beta terms, are estimated by minimizing the sum of squares of the errors. And we showed how to do that, and this is why this is called ordinary least squares regression. Whenever you come up with a model, you need to remember to test and see how good it is. And we did two basic tests. You want to look at the goodness of fit, check the R squared, make sure that's sufficiently high, you're explaining something. And then you also want to check each of your coefficients to see if they're statistically significant. Now you want to use your judgment here, just as we did when we had the indicator for school being in session, because the statistical significance was borderline. It was a 0.105, and I chose to keep that in. So use your judgment here, and the p-values and all those are guides. Some warnings though. Whenever you do regression, you need to make sure and understand that what you're doing is you're finding mathematical correlations between these independent variables and one dependent variable. You're not finding causation. Even though you think, the school's in session, that's going to drive sales, you're just finding a correlation. It might have nothing to do with it. It might be something totally unrelated. It might just be school's in session during time when people like to drink coffee. So you need to make sure you're not making the statement that it's a causation, because all we're doing is finding mathematical correlations. But we're trying to forecast, so that's okay. We're just trying to find repeated correlations that are consistent, because then I can rely on those for my forecast. You should also avoid overfitting of data. We gave an example of that. Remember, what you want to be doing here is forecasting for planning purposes. The objective is not to get the highest R squared possible. It's to come up with a plan that you can use for their forecast. So we found that this was actually pretty easy to use once you figured out how to use the LINEST function, and in most other packages it's even easier. So why don't we use regression all the time instead of that painful exponential smoothing with all the bookkeeping? Well, there's two main reasons. The first is, look at what regression is doing with the data. It treats all data the same regardless of age. So the observation that's 2 years old is just as valid as the observation that happened yesterday. So just like we had issues with using moving average and the cumulative models, we're treating all that data the same, so does regression, and that's not necessarily a good thing. That's the benefit of exponential smoothing. We degrade the value or the weighting of the observations with their age. The other thing is the amount of data that you store. You need a ton of it when you do regression. You have to keep all that data here. So this is why exponential smoothing is still widely used. However, regression is very powerful, and especially for capturing the effect of events. For example, if I run a promotion, if I run a series of promotions, I can start getting a good handle using regression. What is the lift or the sales increase for certain types of promotions or certain types of discounts? And once I capture those, I can embed those in my forecast going forward. If I plan, say 2 months out, I'm going to run a promotion, I could do my normal exponential smoothing and then layer on top what this increase in the promotion will do. So at the end of the day, you're not going to use just one tool. You'll probably use a combination of these. And so whether you use regression to understand the impact of individual events, and you embed that within exponential smoothing to capture the more general patterns, that's all okay. And that's what's commonly done in practice. Okay, I hope this was all useful to you and you used the knowledge here to work the quick problems and work some of the practice problems. If you have any questions, comments, or suggestions, please use the discussion.